Okay, so on to question 6. A generic gas X is placed in a sealed glass jar and decomposes to form gaseous Y and solid Z in the following reaction. So let me write down this as well. 2X as a gas decomposes and forms Y plus Z. How are these equilibrium quantities affected? By the initial amount of X placed in the container. Assume constant temperature. Okay, so I'll just write down all the different quantities that are affected by the initial amount of X. So when the concentration of X changes, then both the mass of Z, which is the product, this changes as well. Obviously, because the more X you have as a reactant, the more Z solid can be produced. So when the concentration of X changes, then the two gases, which is X and Y, their concentrations change as well. So obviously for X, that will change, and the concentration of Y at equilibrium changes. Okay, so since Y is a gas as well, if there was more or less of our initial X, then that means the pressure inside this sealed glass jar will change as well. So I'm going to just say total pressure changes. And the only thing that stays constant is kind of the rate of reaction between the two gases, X and Y. This at equilibrium is constant. Okay, so let's see what the junior tutor said. A decomposition reaction is a reaction where a reactant breaks down into two or more products. In this decomposition reaction, it can be said that the rate of the decomposition does not depend on the amount of substance initially. Yep. So this last point can be described as the rate of decomposition. And the reason why the X is squared is because in the balanced chemical equation, there is a coefficient of 2 in front of the X. So that's why it's important to balance your reaction equations, because this in turn will affect the rate of the reaction. Okay, so to continue, it can be said the rate of decomposition does not depend on the amount of substance initially. In the problem, the compound disappears and new two compounds appear. The rate of the reaction is usually observed by watching the disappearance of a reactant or the appearance of product. In general, it is the change in concentration over the change in time. Okay, so they show how you would find the rate of the reaction is equal to minus 1 over n times the change in concentration of reactant divided by the change in time, which should also be the same rate as the concentration of products, the change in the concentration of products over the change in time. Yep, so this solution is correct. I'll also just add all the other equilibrium quantities. Okay, so I said that this solution is correct. The rate of the reaction at equilibrium is constant. Factors that are affected by the change in the concentration of X are, I'll put X, the mass, are the mass of Z formed, the concentration of X and Y at equilibrium, and the total pressure.